So this is the second day of the workshop. So just 5 minutes, I will just brief about summarize the yesterday's
Need.
concept. So as part of generative AI, finally what it will generate based on the user prompt, text to text content, text to images, and it can generate audios, videos, and also programming language codes it can generate. You can reverse them also. Image to text you can convert, audio to text, video to text you can convert them. Okay. Suppose if you give any code, if you give explanation about that code, it will explain you the programming language code also. So this is what the meaning of generating AI, what exactly the purpose of it. Okay. So it is actually not an extension to the artificial intelligence, it's a sub-department of the artificial intelligence. Okay. But nowadays there is special importance and special boom for generative AI. That's why we are going to learn this. And before that, one small point. If you look into the Google Translator or Alexa, so these are already based on the generative AI models only. Of course, in the olden days, there is a special algorithms called GAN. GAN. Okay. Generative Adversarial Neural Networks. So by using such kind of models in the deep learning, machine learning, the generative AI models have been developed. But nowadays, the developer need not to worry about entire data science or artificial intelligence because already predefined algorithms, predefined libraries are available. You just as a developer, you just need to know how to call them, how to use those APIs. That means libraries. Okay, step by step. After day after tomorrow class onwards, we are coming into the practical part. There you will be learning how to use that. So for this, we have different APIs, especially for generative AI. What are the popular APIs is OpenAI, LangChain, Hugging Face, Llama. Such kind of APIs are available. All these APIs can generate text, images, audios, and also videos. Even music content also it can generate. If you give basic context, even it can generate a story also. Okay. So many things, many use cases are there. So we discussed about like chatbot development and what is the advantage of the chatbot development and everything. So what are the main advantages of the chatbots? Look into this as per our yesterday's discussion. Look into the advantages. So point number one, your chatbots never died and always 24/7. Those will be on the live. They never sleep. Okay. At the same time, any number of users can question and they can get their answers. So ChatGPT is one of the best example, but that is for public information. Okay. If you want to, as a developer, you need to develop your own GPTs. That means your own chatbots. Okay. So yesterday I told you to learn all these things. The minimum prerequisite idea that is about machine learning. The machine learning basic models and how exactly those works once you have that idea. Okay. So you can learn all the things from the generative AI models. So today, as part of the day number 2, I'm going to start about machine learning introduction. Machine learning, and also there is another concept called deep learning. After that, you can understand what exactly the combination of ML and AI, artificial intelligence. Come on, sir. Anyone have idea about this machine learning? So please try to interact
Machine
with me.
learning and deep learning are subset of AI.
1 minute, some little low voice. Come on, please. No problem. Even though answer is wrong or right, it doesn't matter. So try to interact with me. What exactly the machine learning?
We have to teach the features to the machine.
Teach the features. Okay.
Machine learning is the subset of AI, and deep learning is the subset of machine learning.
You said answer number 2, the subset of AI, and also vice versa, you said. Okay. Still any other answers? Okay. So ML is not a software, remember, is not a hardware, is not even an operating system, is not any other thing. This machine learning is an approach. Approach for what? To try
Train and test the data.
mathematical models. To train mathematical models with the data. So based on this definition, the first answer is almost 70% accepted. Okay. It learns from the data features. So here, especially here, two things I want to ask you. You said to train is an approach to train mathematical models. Then the thing is, who is trainer? Point number one. You are giving training means there should be some learner also. Who is learner? And then with what trainer will try? These are the three questions. Just by seeing this
And
definition,
with machine learning algorithms.
first you tell me who is trainer. Suppose in our case, I am trainer, you are student, you are learner. In machine learning point of view, then who is trainer? Who is learner? With what trainer will train the learner?
With
Who
a
is
model trainer.
No, you are trainer. Okay, you are trainer. Who is learner?
Mission.
The data.
No, not mission. Model is learner. Just observe this. To train mathematical models. That means your student is a mathematical model. Got it? You are going to train a mathematical model with help of what? Data. All of you got it? Okay, let's come to this story. I'm a human, you are a human. I have brain, you have brain. That means I have thinking ability, you have thinking ability. That's why I can train you. But here, you are a trainer, but your learner is not a human. Your learner is a model. Your learner is a model. Model doesn't have brain. Okay. Model is just a mathematical equation. Got it. Then how to train a brainless mathematical model? Okay, that is the approach. Got it. So you are a trainer, learner is model with help of data. Okay, with the help of data, you will train them. Got it. Then immediate my question, how a brainless mathematical model will get right? This is the question. Okay, the approach is very simple. Just observe. I take one picture to make you understand about this. For some time, treat that your age is 3 years or 2 years. You're a kid. Your father wants to train you about animal detection. Father to kid. Treat this father is a trainer here. The kid is a learner here. Okay. So objective of the model is, objective of the training is recognize animals. Let's say whether the pic is about a dog, the pic is a cat or tiger, etc. So about this, he wants to train. Your father wants to train you. Now your age is 2 years or 3 years. Okay. What is the father approach? Maybe in the live or maybe with the images. Think that pick one he is giving you. He is showing you. Think that pick one is a dog. Okay. And he is saying that this is a dog. Okay. Here pick means that image pixels. These are called features. The dog is a label. He is showing one pic and he is giving a label to you. And he is saying that this is a dog. This is called label. That means here you can understand data contains two things.
And it's one of the type of the supervised learning, right?
Yes, supervised learning. Again, if you come into the opposite, unsupervised learning, there is no label. Okay, later we will discuss about what is unsupervised, supervised, reinforcement, everything. Okay,
Yeah,
that
sure.
contains two things here. One is features. Second one is label. Okay, for easy understanding, I am writing these labels in the text format. Generally, these labels will be in the numerical format. Okay, think that this is a day one training, sir. Okay, so first time you are seeing one animal, right? So before this training, you don't have any knowledge to recognize the animals. Okay, in the day number, as part of the day number one training, your father presented a pig and he is giving a label called a dog. Now, what might be the understanding of the baby whenever this program started? After completion of the day one, what might be the thinking of the baby? So up to now, she has seen only two-legged beings like mother, father, relatives. Everyone has two legs. First time, the baby has found out four legs. Now, baby thinking might be, okay, two legs, that is human, four legs, that is a dog, after completion of the day one. This might be the thinking. Okay. So after that, in the second day, father is presenting a pig number two. Actually, in fact, this pig is think that this pig is about a cat. The pig two is a cat, not dog. And he is, by showing this pig and he is asking the baby what this is. Now, what might be the answer of the baby?
Dog.
Why? As per
Because
yesterday
it's
knowledge.
in
Yes, yes. As per yesterday knowledge, for baby understanding is 4 lakhs, that is a dog. So as per that knowledge, in the day two, it explains that pick two as a dog. Now immediately, when our baby said dog, what father is doing? Father is correcting that. No, this is not dog, this is cat. The father is correcting that. Understand this point? Okay. Now, after completion of day two, when our father corrected the baby, what was the thinking in the mind of baby? She started a deeper digging about unique distinctive features of the dog and cat. Maybe after some analysis, she might find some differences between dog and cat, maybe at the size, maybe at face, maybe at waist. Okay. Somewhere she will find some distinctive features. So now after completion of day one, that knowledge level is something. After completion of day number two, the knowledge is different. That means after second picture, knowledge got improved. That means error in the mind got decreased. In this way, pick three, maybe of a dog with a different breed. In the pick four, in the day number four, maybe cat, pick five. It's maybe again cat. In this way, Think that 100 days training completed. It's about another breed of dog. So with the different sizes, with the different breeds, he presented multiples of dog varieties and cat varieties. Now think that the training got completed. Got it. Now after completion of 100 days, what is the knowledge level of the baby about to recognize a dog or cat? The knowledge is more matured when compared with initial days. Okay. Now father feels that the training is completed. Now he wants to test. He wants to test. This is called accuracy testing or model evaluation. Okay, for general word, I am saying it as a test. Randomly, he selected pick 1 and pick 50 and pick 80 and pick 99. And he is asking the baby. She said that this is a dog. Next, pick 50. This is pick 50 is about cat. Pick 80, again, she is saying that cat. Pick 99, it is saying it as a dog, like this. In this way, 10 random picks he has presented, baby answered all the things well. Of course, like out of 10, 9 answers correct. Now, what is the percentage of accuracy of the baby? Which is 90%. If father satisfied about this accuracy, he will stop the training. If accuracy not satisfied, he will retry. That means with more pictures, he will train the baby again. Got it? So in this context, in this example, in this story, if you look into these features and labels of this data, the data contains two things, features, labels. The picture is a feature. The label for that picture is, that means dog or cat, that is label. But in fact, here father did not train about any biological features. Only he presented data. Automatically, baby is grasping that knowledge. Got it? Here, in this example, as a machine learning engineer, this is you. Your kid is a mathematical model. Got it? With help of data, with the help of some algorithms, mathematical algorithms, he trained the predictive model. Got it? So same kind of approach we will follow into the machine learning. And one more accurate, more meaningful example I will demonstrate. I will explain one more thing. All of you understood the previous example. Who is
Yes.
learning, who is trainer? Okay. Think that this is a tree. It's a mango tree. Think that these are the fruits. Now again, your age is not 20 plus, your age is 4 to 5 years. Okay. You have different stones here. Now the task is, with help of these stones, you want to hit this fruit. Okay. You don't know how much force should be applied, in what angle you should hit that. You don't know the exact measurement. But still, you are desperate to hit that fruit. What you do, your style is what? You do different random styles. Think that this is trial number 1. The trial reached this one. That means some random force you applied, some random force and random angle you applied. Let's consider like a speed and angle. Okay, the fruit, the stone reached up to this one. But there is a huge gap between the reached area and your destination. This is called error. Think that if there is a mechanism to calculate that error, in the beginning I got error 200. In the beginning I got the error as 200. So this error because of what? This error because of one wrong force and one wrong angle. Okay, after that you realized there is error. Now your next target is to reduce this error. Automatically you will pick one more stone. You will modify your parameters. I mean your weights. These parameters are your force and angle. In the trial number 1, you got 200 error. The next target, in the trial number 2, the error should be reduced. Maybe you took a second stone. Again, you are doing a trial. This time, it reached this one. This is second trial. Got it. Now, still there is a difference. This is our second error. But this error, when compared with the first error, is definitely less than. Okay? Think that now this time, the error is 30. Again, you are not satisfied about it. You are doing third trial. The third trial is like this. But still error is there. But this time, the error is maybe 5 units. How to calculate that error? There are different methods. In practical part, I will demonstrate. There is error 5. Again, our target to reduce that error. Again, you are doing modification in the force and angle. And you are doing the fourth trial. In the fourth trial, you hit that fruit. That means in this moment, the error is 0. Got the point? That means finally what is deciding whether you hit that fruit or not? A right force, one right angle is controlling that one. But initially you don't know anything. Initially you don't know anything. With what force, how much force should be applied, how much angle should be applied, you don't know. You are doing a trial one, you got error. Again, your next target to reduce that error. Again, you are doing second trial, third trial, fourth trial. In this way, maybe 100 trials. Maybe with one or first trial, you will succeed it. Whatever the force you applied in the last trial, like a right force, right angle, that is a correct knowledge. Suppose if you did 100 trials, first 99 trials are bad knowledge, but in the 100 trial, that is a good knowledge. Automatically here, no physics teacher, no chemistry teacher, no mathematics teacher did not taught you how much force should be applied, how much angle should be applied. Automatically, the boy, the kid has learned that one by doing trial and errors, trial and errors, trial and errors. This is called actual machine learning approach. Okay. So now let's come to some basic, very basic. I hope all of you studied 10th level mathematics, 10th class level mathematics. Okay.
Yes.
Even I am not coming to even 10th class also. I am coming to very basic 8th standard mathematics. Have you seen this equation? Y equal to mx plus c. Y equal to mx plus c.
Right.
Yes, sir, right? What is this? What is this equation?
Slope to
M is slope, okay. C is a constant, okay. Y equal to
Linear.
mx plus c. This is a equation.
Linear.
No, don't say linear, because still we did not come to that linear model. We can say it as a straight line. Got it? It's a straight line equation, right? So generally here, what is a model, first of all? Model is a mathematical predictive equation. Mathematical predictive equation, right? But every equation, this is a equation. This is a equation, but this is not a predictive equation. This is just a math equation. But here, what we said, mathematical predictive equation. That means the equation should give some prediction. Okay. So to give you clarity, one more picture I will show you, so that you can understand the difference between a mathematical equation and mathematical predictive equation. I am taking age of some 100 people. I'm keeping age in the x-axis and their income in the y-axis. Suppose I collected data from some 100 people. Suppose first person age maybe 20 years, his income maybe 30,000. Second person, third person, fourth person, fifth person, sixth person, seventh. In this way, I collected data from some 100 or 1,000 people. I plotted them in a graph. The shape is like this. Come on, sir. Now you answer me. If I talk about this, y equal to mx plus c is a straight line equation. How many straight lines you can draw across these coordinate, across these points, plotting points? How many straight lines you can draw? Only the condition, the straight line should go across these points. So please do quick response.
Only one straight line.
No, unlimited number of straight lines you can draw. Our condition is what? The line should go across these points, that's it. I can draw a
Infinite
line like
lines.
this, I can draw a line like this, I can draw a line like this, I can draw one more line, one more line, one more line. In this way, how many lines you can draw? Unlimited number of lines you can draw.
Infinite.
Yes, infinite number of lines. But only one thing, only one line is optimized closest distance to all other points. Look into the red line, please, all of you. That is optimized closest distance to all other points. Okay? That line is called regression line. This line is called regression line. Got it? This regression line is used as predictive line or equation. Okay, the equation for this in terms of machine learning, y is equal to w0 plus w1 into x. That means your income is equal to w0 plus w1 into h. In the place of x, I kept age here. In the place of y, I kept income here. Okay, look into the second equation. If I know your age, I should be able to predict income. I collected data of 1,000 people. Based on this, think that by using some statistical method or mathematical method, I calculated W0 value and W1 value. Got it. I calculated that value. So once if I know W0 and W1, next onwards, if I know your age, I could able to predict your income. So this is what like a basically, even in the image detections also, if I see your facial features, I could able to guess your age. Got the point? So similar to that, if I know your age, next onwards, I could able to predict your income. This is what a predictive equation. Okay, again, look into this second equation, second line, income is equal to W0 plus W1 into H. Based on the given data of 1,000 people, what you know, what you don't know? Please answer me. What you know, what you don't know?
We know age.
Yes, you know your age, you know income also. Got it? You have 1,000 people data, you know all 1,000 people ages, all 1,000 people's income, you know, but you don't know what is that parameters, what are that parameters like W0 and W1. Okay, this is as per machine learning terminology, these two things are called weights. These two things are called weights. Okay, So the weights constructs a relationship between features. Here features means age. Inputs are called features and labels. Labels means target. So in this example, based on the age, I want to predict income. Understand this point. So finally, with the help of machine learning, I want to find out this W0 and W1. That too not by fixing a formula. Okay, the model itself has to do self-learning. What is the how machine learning approach will follow? We will discuss now. Sir, forget about notes. This recorded session will be shared to you. Yesterday's session also we have shared to you. So after completion of this session, by afternoon you will get this session also. Come to this, I keep some data. I am collecting some patient's data. Patient age, patient height, weight, and height, and his cholesterol. Got it? And his cholesterol. The first person age is 25. His weight is 50. Height is 6. Cholesterol level is 20. Think that this is one of our first patient details. Next patient 30. Weight 90. Height 5.5. Cholesterol 80. In this way, you have collected data of 1,000 patients again. Okay. The last patient details. 80 is age. 60 is weight. Height is 6. And cholesterol 45. So this is the data. Now the task is like this. Totally 1,000 patients you have. My task is like this, based on age, weight, height. Predict cholesterol. Predict cholesterol. Got it? So here, as per this example, as per machine learning terminology, what are features here? What are features?
Height, weight, and age.
That means age, weight, height. These are the inputs. Inputs are called as features. Okay. What are labels here?
Cholesterol.
Cholesterol. Got it. So in machine learning terminology, you need to prepare two matrices. One is X, another one is Y. Okay.
Yeah.
It's a matrix 1. It's matrix 2. So X is input matrix. X is always represents for features. Y is for labels. The first patient details. I'm keeping number 1. His age 25. Height, weight 50. And 6 is the height. Second patient, again I am keeping 1. The first line 1 I kept, later you can understand, that is for the bias. Okay, some hidden force will be applied. Later I will explain, in the mathematical part I will explain how you got 1 into the first column. So matrix means is the arrangement of the data in the rows and columns format. I'm taking second patient, 30, 90, 30, 90, 5.5. Last patient, 1 again, 80 is the age, 60 is the weight, and 6 is the height. Totally, what is the matrix size here? If I have 1,000 patients, for all the input matrix, just keep ones in the first column.
1,000.
1,000 rows, right? I have 1,000 patients. How many columns I have? How many input
4.
variables? Input variables 3 plus extra column 1 for bias. Totally 1,000 by 4. This is my size of X. What is the size of Y?
It will be 1000 into 2.
Y means labels. Y means labels. Y means labels. Only labels will be there. So first patient cholesterol 20. Here no ones. Okay. And second patient 80. Third patient, like this last patient, 45. What is the size of this Y?
1000 by 1.
1,000 rows because 1,000 patients. How many columns? 1 column. Okay. So as per matrices, as per linear algebra, the mathematical prediction is Y equal to X dot W. Okay. W means here X is input matrix. Official name for this as per machine learning is features. Y is labels. And W is weight. So what is the role of weights? Weights are constructing relationship between features and labels. Now look into this equation. This is what mathematical predictive model. If you look into this equation, Y equal to X dot W, here dot indicates matrix multiplication. No need to worry how to calculate matrix multiplication, how to do matrix inversion. All these things are not required because we are using programming language. All predefined functions will be there. Okay, just observe. Y is equal to X dot W. Here X is patient's input features. Y is labels. As per this equation, what you know, what you don't know. I repeat the question, what you know.
Input labels known, weight and
That means you know features in the form of X, right? You know labels in the form of Y matrix. You don't know
Weights.
weights. Got it? You don't know weights. So statistical approach is different. You are fixing some formula, you will calculate the W. But machine learning style, the model itself has to do self-learning about that weights. Your model has to learn the relationship between features and labels. So for that, what kind of approach the machine learning will follow? Just try to understand. Okay. Same as per previous example. What is the size of X? Size. 1,000 patients.
1000 by
1000 by 4.
4. Okay. What is size of Y?
1000 by
1000 by
1.
1.
1,000 by 1. Okay. By 1. Okay. Now, let's have a picture to understand style of machine learning. How many input variables I have? As per previous data, A is weight, height. Okay. Treat this as age. It's a variable called age. This is weight, person weight. This is height. Already in the matrix, did you observe? We kept 1. This is for bias. This left side for input variables and bias I kept here. Come to the right side. This is for my target. What is the target?
Cholesterol.
Cholesterol. This is cholesterol. Got it. Come on, sir. Age with some force. is controlling the cholesterol. Weight has its own force on cholesterol. Height has its own force on cholesterol. Bias, some hidden force, is hitting the cholesterol. Treat this as W0. That means that is called bias. This is a slope of age. That means with how much force the age is hitting the cholesterol. Age has some impacting power on the cholesterol. That is called slope over here. Simply treat it as weight of age. Okay, this is W2, weight, person weight. This is weight of height. Now, if you treat this W, capital W, I am giving for the weights because our predictive equation is what? What is our predictive equation?
Y equal to X into W.
X dot W. Got it? So already you know Y. You know X size is 1000 by 4. You know Y? 1000 by 1. Then what might be the size of this W? What might be the size of this W? How many weights here in this picture?
4.
0, 1, 2, 3. That means 4. Got it? That means the size of this one is 4 rows. 1 column. 4 rows, 1 column. Now, what is come back to the tree, mango tree and kid example. There are two weights. One is for force, second one is angle. There are two weights. Initially, what the kid has done, he has taken some random force, random angle. That means random weights he has taken. Got it? So initially, it will take random weights. Let's say, easy example, this W. Initially, the machine learning model takes random weights. These weights I am taking like this. 0.2 minus 1.3, 0.6, 0.9. On that way, some random bias, random slope of age, random slope of weight, random slope of height it has taken. Now, this is our first step. Got it? Now, come to this prediction. It applies the prediction now. The prediction Y cap. Or else like Y small p, Y prediction. Y for cholesterol prediction. The predictive equation is X dot W. What is the size of this X? Size of X? 1000 by 4. What is size of W? 4 by 1. What is the result?
1000 by 1.
1000 by 1. That means if you apply the prediction, you got 1000 predictions, right? You got 1000 predictions. Got it. With random weights they have taken. But actually, first person cholesterol is 20. Predicted cholesterol is 2. Think that this is our first person is you. Your actual cholesterol is 20. But prediction is saying that with random weights, it is saying that as 2. Is it correct prediction or wrong prediction?
Prediction.
Wrong prediction. Got it. This is called error. Understand? In this way, for the first patient, 1 error we got, second patient, 1 error we got. If you have 1000 patients, 1000 errors you will get. Understand? To calculate all the errors, overall error, there is a technique called MSE. How to calculate that MSE in the mathematical part we will see. MSE means mean square error. Okay? Mean square error. You calculate the error. In the first iteration, I got error 190. Got it? After that, this error is a big error. Next, the target is to reduce this error. To reduce this error, there should be some adjustment should happen in the weights. Some adjustment should happen at weights. If weights got modified, automatically this error will be reduced. To modify those weights, what system does is, what model does is, it applies a derivative. The derivative is exactly working like a compass. Okay, always it targets to reduce the weight. Because in the first trial, you got error 190. In the next trial, the error should be less than 190. On that way, it applies one derivative. This derivative symbol simply called as delta. Okay, what is the formula for the derivative? How to apply with the system in the practical part? We'll see. Okay. After that, you got this delta produces adjustments in the weights. The weights. Got it. The size should be exactly same as weights only. That is 4 by. Got it? So up to now, what happened? By taking random weights, it applies a prediction. After that, calculated the error. In the next iteration, to reduce that error, it applied derivative. The derivative produced weights. After that, in the next step, it will adjust the weights. W plus equals to this delta. That means whatever the previous weights we have, which are random weights, for those random weights, it has added this delta. Now these weights will be modified or not after completion of this step. After completion of this W plus equal to delta, these weights will be modified. Now latest W, we got it. With latest W, again it applies a prediction. Again it applies a prediction. Again it is calculating the error.
I had a doubt that bias will remain constant or will get changed at each time.
Bias will also be changed. Because in
Okay.
the beginning, the bias is 0.2. Now after completion of this W plus equal to delta, it might be 0.5.
Okay.
Okay. Every iteration, every parameter will get changed.
Okay. Thank you.
Now you are at second iteration. In the second iteration, what happened? With the latest delta, with the latest W, again it applied a prediction. Again, at each prediction, there is an error. It is calculating overall error, which is called MSE. But this time, if you really check, error should be less than 190. Think that it is 120 right now. 190 is first iteration error. 120 is second iteration error. What is the difference between them?
Little bit more accuracy.
That means which error is best? Both have errors. Which error is best?
120.
Definitely the second iteration. That means latest iteration. Got it. Okay, now up to now we have two versions of W. First version W, second version W. Which version is good?
Version
Second.
2.
Huh? Hello?
Second
I have
version.
two versions. Yes, definitely second. If you treat that W as a knowledge, which version knowledge is good?
Second version.
Definitely second version knowledge is good. If you treat that W as a knowledge of the model, second version is good. Got it? But still there is error, right? Still there is error, right? Again, to reduce that error, what it does is, again, it applies a prediction. It applies a derivative. Just wait. It applies a derivative. Again, derivative produce adjustments. Again, delta is produced. This delta is added to, after this delta is added to W. Now you got a third version W. With the third version W, again prediction. Again calculating error. This time error is 10. Still error is there.
Yes.
Still error is there. That's why again it is applying derivative. After that, it is adjusting that adjustables, I mean delta to the W. Now 4 versions of W. Again in the 5th iteration, again it is applying prediction, calculating error. This time my error is 1.2. Again error got reduced. In this way, iteration 1, we got 190. Iteration 2, we
120.
got 120. Iteration 3, we got 10. Iteration 4, let me check what we have written here.
1.2.
1.2. 1.2. In this way, think that iteration 150 also completed. Okay. At that moment, the error is 0.004. Okay. But even though 0.004 still error is there, right?
Yes, sir.
Okay.
Yes.
Okay. Think that again it is applying the derivative. Again it is doing adjustment. In the iteration number 151, I got a result called 0.004 again. What is latest error, sir? What is latest error?
0.004.
What is previous error?
0.00.
That means current error and previous error both are equal, right?
Yes, sir.
Sir, I need your observation here. Current error and previous error both are equal or not?
Yes, sir.
Whenever it became equal, the training got completed. Understand? So
Yes,
here,
sir.
look into the first iteration, 190. Second iteration error is what? 120. Both are different or not?
Different.
Yes.
Different. That's why training not completed. That's why it is performing third iteration. So, again, both are different.
Yes,
Yes.
sir.
That's why training will be proceeded. Continue. Look into this, 150 and 151. Both are equal.
Yes, sir.
Training completed. That means now onwards, how many iterations if you train, the knowledge won't be improved. In the 150 TI also, you will get 0.004. In the 153 also, you will get the same thing. That means you will pass a condition. If current error equals to previous error, then break. That means the training loop will be completed. All of you understand the approach? Okay, think
Yes,
that in this way, 152 iterations completed. Sorry, where is that picture? In this way, 152 iterations completed. Like how a kid is trying to hit that mango fruit, trial 1, trial 2, trial 3, like that, totally 150 plus iterations completed here. That means how many versions of W that you have? How many versions of this W you have?
152.
152 definitely. At each iteration, what is happening to the W? At each iteration, what is happening to the W?
Delta values changed.
W's keep on modifying or not?
Yes,
So
sir.
W's keep on updating or not?
Yes, sir.
If you treat that W as a knowledge, for every iteration, knowledge is improving or not? Error decreasing means knowledge improving, right?
Yes, sir.
In your brain, if there is a ignorance, as ignorance is decreasing, your knowledge is improving, right? Similar to that, as error is decreasing, knowledge is maturizing. That means knowledge is increasing. Understood? So whenever the training got completed, we will consider last iteration W as a knowledge of the model. Previously, our model doesn't know anything. Now your model knows everything, which is better than a human. It can do the prediction. Even better than a doctor, it can predict a cholesterol. Once if you try this. Understood? So this is what exactly the approach of machine learning. Come to this, what are all the steps we did here in a rough way? So in our picture, what is the step one we did? Your doctor has given you 1,000 patients data, maybe in the file or maybe in the database, or maybe in some other cloud file system, okay? And he has given you, the hospital management has given you 1,000 patients data. Got it? Now, what's the next step? What's the first step you did? You prepared feature matrix, which is simply X. How to prepare that? You'll be learning in the practical part. Let's say you have 1,000 patients, 1,000 rows, and 4 columns. And step 2. Look into this step 2. What's the next step? We did
Label matrix. Y.
label matrix Y. Let's say Y. This is 1,000 patients. Of course, you're trying to predict only one column. That is cholesterol. That's why 1. Step 3. Look the peak and tell me.
Predictive equation.
Predicted
What?
weights.
Pardon? Come again?
To form a predictive equation.
Predicted weights.
The first step you did random weights, right? Hello.
Yes, sir.
That means initiate random weights. That means random weights treated as a bad knowledge, very bad knowledge. Okay. Initiate random weights matrix. What is the size?
4 into 1.
4 into 1.
4 rows, 1 column. Now, up to now, basic steps, prerequisites completed. What are the prerequisites here? Based on the given data, preparing input matrix, that means feature matrix, label matrix, weight matrix. After the first step is what? Training. Training is this circle is training. In what way you are giving the training? By taking the random weights, apply the prediction, calculate the error, apply the derivative for the adjustments. After that, adjust the weights. This is called training. Okay. Step 4. Training the model. What is your model? In this example, what is your model? Model means what? Predictive mathematical equation. What is that here? Y equals to x dot,
X dot W.
right? This is your prediction. Predictive equation, training the model. Okay. Loop begins here. That means training loop. Step 4.1. That means in the training loop, first step, apply prediction.
Prediction.
What is the equation? Y equal to
Y equals to
x
W.
dot
X dot
W.
W.
Step 4.2. What is the step 2? Once prediction is applied, what you are doing? What you are doing? Calculating error.
Calculating error.
That means measure MSE. That means error of the
Error.
model prediction. Okay, this is also done. Then step 4.3. I got error. Next, my target is what? To reduce that error. To reduce that error, what I need to do?
Derivative.
Apply derivative.
Apply derivative in weights.
And find delta. Okay, what is that delta? What is the delta?
Adjust all.
Adjustments to
Predictive. previous weights.
Previous weights. Okay, next step 4.4. What is the final step?
Treat weights
Just
or
the
adjust weights at the delta.
weights. That means W plus equals to delta. Of course, there is another thing called into alpha. What is that alpha? What is the importance of alpha? This is called learning rate. What is the importance of learning rate? Later we will discuss. Just to try to understand the mechanism. Okay, step 4 completed. That means the step 4 adjustments also completed. Do I need to proceed to the next loop? Do I need to proceed to the next loop? Or you want me to stop? Sir, expecting answer from you. You want me to
Please
proceed or
proceed.
you want me to stop?
Proceed.
How? How? I know. If current error equals to
Equals to previous error,
previous.
then break.
Okay, then
Break.
if this condition is true, then only
Then break.
I will break. Otherwise, the loop
Will
completed.
continue.
Here loop. Got it. It may take 100 iterations or based on the data patterns. It may take even 1,000 patients or 1 lakh iterations also. Finally, how your model knows like this training is completed based on this logic. Current error, previous error, once it met convergence, then the training part will be completed. Now, this is the approach how you are training a model. How to train a model. Now come back to the beginning discussion. Look into the beginning today's sessions. The beginning statement is an approach to train mathematical model with the data and algorithms. Suppose in this example, whatever the algorithm, the derivative algorithm you have seen, this is actually the algorithm. The style of this algorithm is by taking the random weights, apply prediction, calculating error, to reduce that error, apply the derivative, and adjust the weights. This kind of the name for this algorithm is called gradient descent algorithm. Now you are a trainer. In this picture, by seeing this picture, who is our student? In this picture, you tell. You are a trainer. Who is our student? That means who is our learner?
Cholesterol, ma'am.
No. Cholesterol target variable.
X.
Predictive mathematical equation is our student. Model means, model is our learner. Model means what? A mathematical predictive equation. In the mathematical predictive equation, what you know, what you don't know. You know X, I mean features. You know Y, I mean labels. What you don't know, W. Automatically your model finally after completion of all iterations, your model will acquire a good knowledge better than a human. Understood that points? So that is what the meaning of the beginning statement is, an approach to train mathematical models with the data and algorithm. Here, what is data? What data contains? Data contains two features, labels. And with algorithm, what is that algorithm here? Of course, different algorithms. One of the algorithm is gradient descent algorithm. So this knowledge is enough to get into that deep learning kind of models. And also next you can get into generative AI models. Okay. No need of any strong typical mathematical backgrounds. Once you know how to prepare a matrix, how to clean a matrix, okay, remaining everything Python will take care of. Because in Python, for the matrix preparations and matrix related calculations, we have a special module called NUMPY, NumPy. Okay, so everything you will be learning just right. Please, you got clarity about these three questions?
Yes, sir.
Who is trainer, who is learner, with what a trainer will try. So here better answer for the third line, data plus how. Got it? You will train the model with help of data and also algorithm.
ML algorithm.
Okay. Yeah. So what are the process we discussed in this paint? This answer. This is the answer for this last question. How a brainless mathematical model will get right. Got it? So in machine learning, you have different approaches. These things are called types of machine learning. Okay. So this knowledge is another important thing. So in tomorrow's session, we will be discussing about types of machine learning like supervised machine learning, unsupervised machine learning, reinforcement learning. Because in the AI field, we will apply combination of supervised and reinforcement. Okay, first of all, you should know what is reinforcement, what is unsupervised, what is supervised. Okay, tomorrow entire session we will dedicate for this one. Okay, and day after tomorrow onward we start with the practical part. But tomorrow session is mandatory to understand after tomorrow session. Okay.